Hey everyone, hi again. Thanks for joining. This is our 22nd core dev call. Let me go full screen. 22nd core dev call. As always, some context. These core dev calls are for core contributors to present what we've been working on, update the community on what's coming, and discuss upcoming features and protocol changes with community members like you. While there's time for Q&A after each topic, and I'll share the agenda in a bit, you're highly encouraged to continue the conversation over forums, Discord, GitHub. Everything is out in the open, and we do want your feedback. So I'll paste in the show notes and this chat a link to our ecosystem calendar so that you can be subscribed to future calls. Lastly, if you haven't seen it, core dev teams are now posting monthly general updates in the forum, and I highly recommend you to check this out. It's a lot of good data there. So I'll share this link too. All right, so today's call might be a little shorter. That's than usual. So there's a lot of, there's a holiday season. And so we'll have 45 minutes instead of the full hour, and we'll possibly be wrapping up earlier. We'll see, basically depending on how Q&A sessions will go. So agenda, first, Scalar Tap. Tap stands for Timeline Aggregation Protocol, and that's an add-on to the existing Scalar microtransaction system developed by GraphCore developers a couple of years ago, and that is currently being used by indexers to track and settle payments for queries. The new protocol reduces the trust assumptions primarily between indexers and gateways. This is an incredible fit resulting from a close collaboration between Semiotic and I, Edgenode, as well as other external reviewers. And today we'll be hearing from the Semiotic team on the details of this GIP that's currently in the draft form. So yes, fairly excited to know what this upcoming upgrade will mean for indexers as well. So secondly, we'll have the Geo Updates. Yaniv from Geo, Graph Council member. I'm always curious to know what's new here. Substreams JS, Sebastian, aka as Fubi, you might know him, Graph Council member too, and a core contributor, will walk us through this new TypeScript library for Substreams, suitable for front-end developers to explore and consume Substreams modules. I'll share some relevant links on all of these soon. And lastly, so the ERC 20 Substream modules, we're doubling down on providing valuable APIs for wallets and portfolio type of dApps with data like users token holdings and balances. And with Substreams, we're confident we can do so for all supported chains. And Denise from Pinax has been making great progress on this front. So we'll hear today how these Substreams-based subgraph is being built and how others can already contribute and also reuse it already. So yeah, that's all from me. Let me stop sharing. Not Q&A, not yet at least. Let's see, we have everyone on the call. Yes, Alexi, you're first. Sevi, Brian, thanks for joining again. You should be able to unmute and present and talk, but if not, just let me know in the chat.
Sure. My computer momentarily doesn't want me to share my screen anymore for some reason, so that's great. This is great timing. Maybe Brian or Sevi, can you share the presentation? I sent the link. Of course, the Murphy's Law. It won't work at the critical moment.
If you folks want me to share my screen, I can also do so. Just send over the link and I can do it.
Okay. Can you see my screen?
Yes.
Hopefully it's on the slideshow.
Yep.
Okay.
Thank you.
Mm-hmm.
Yeah, so yeah, today we're doing a little overview of the timeline aggregation protocol. It's really in relation to the linked GIP. to help people, get some context as to what we're talking about there. So what it is, a trustless, fast, efficient, unidirectional payment state channel, roughly. So that sounds very peppy. So trustless, why we say trustless? Actually, here we have a system that I mean, Zach really coined the term microtrust, whereby the indexer may only lose, in the worst case, up to a certain amount that can be set, right, by the indexer. So it could be, let's say, $1. So at any time in the business between the gateway and the indexer, you will basically optimistically trust the indexer, the gateway, to pay up to $1 and never more. So that's the idea. I'll go more in detail later, but just to give you a rough overview to start with. That will enable query payments from untrusted gateways. That's great, because we'll be able to finally open up safely to more gateway operators. Next slide, please. So fast, because it relies only on the classic elliptic curve cryptography. There's no funky stuff like ZK proof, etc. So that's very nice. And it's only periodically interactive. So from time to time, the indexer will have to communicate with the gateway to aggregate receipts. So and the rest of the time, the indexer just stores the receipts as they come from their queries. Right. Next slide. Was it efficient? Because with this system, the on-chain fee collection is very gas efficient. You just need to check a single aggregate receipt, signed aggregate receipt, right? So it's a single signature check, and then you check the numbers, and you're good to go. So it's very straightforward, very cheap, and that's why also we can afford to say that that we can safely be optimistic with regards to the gateway, is that you can lose up to $1, but what would you lose if you had to, let's say, post a ZK proof on chain, right? Well, you will, on Ethereum, will probably pay $50 to $150. So losing up to $1 if the gateway is evil, it's much cheaper than trying to prove that the gateway didn't pay you later on chain anyway. So it's really great, very efficient. And it's computationally cheap, as already said, yeah. And it's unidirectional, so that's just a detail, but that's what makes it more fast and efficient. It really helps because the payment will only flow in one direction from a payer with a collateral on chain to a receiver that may claim at a later date of their choosing part of that collateral by submitting a signed aggregate that was signed by the gateway. Okay, so now a little bit more explanations. Why do we say timeline? So imagine this is the arrow of time, and the little triangles are receipts that were received over time. Next slide, please. So what we can do here with this protocol is that we can ask regularly for a receipt aggregate voucher. So those receipts were stored by the indexer, and at the indexer at some point, so let's say the indexer gets close to $1 total owed money, for example, they may ask for a receipt aggregate voucher from the gateway. So that implies sending the receipts back to the gateway, and the gateway will sign an aggregate and send it back to the indexer. So the area in blue here is the area that will aggregate in terms of the receipts. So we'll take those receipts and send them back to the gateway, and the gateway will respond with that the aggregate. And after we've received our what we call the RAV, the receipt aggregate voucher, basically any receipts prior to that time, as well as RAV prior to that time, are not eligible for future aggregation. That is, if we want to add to that latest RAV. And so over time, what we do is that, so here, we receive more receipts. As you can see, there's a few more triangles, but we're also asking for a new receipt aggregate voucher at time 5. So what the indexer is going to do is send the previous last RAV, which is at time 3, plus those 3 receipts that are between times 3 and 5 in the blue area. And that now will make any receipts prior to time 5 ineligible for future aggregation, right? And the point to remember here is, why is that secure? Why does it prevent replay attacks? Is that only one RAV may be redeemed per allocation. So the only thing you can do is, if you don't want to submit the latest RAV, you can submit an older RAV if you wanted to, but you'll just get less money. So basically, to get the most money is to get the money you're owed, right? So you can be as greedy as you want, that you'll just get what you're owed. So that's why the gateway is protected. Also, okay. So next slide, please. Yeah. So here's the flow. So these slides are technical slides. Like the next slide, including that one that we were exchanging during development with Edge and Node. And so they're a little bit denser, but maybe some people like the more serious stuff. But yeah, this is the RAV request flow, and so we can see at the top, the indexer is receiving receipts from the gateway. So these are the green rectangles. So some receipts are received. And then at some point, the indexer will decide to request a RAV for the green receipt. During that time, the indexer may have received those purple receipts, but they're not going to be included in the RAV because basically there's some you're taking some margins in terms of the time for which you're requesting the RAVs. So, and so at some point you do receive the RAV from what we call well, now we call it tap aggregator, even though it says gateway aggregator up there, that is operated by the gateway operator. And yeah, then the indexer receives some more of those purple receipts. And at some point, the indexer may decide to ask for an aggregate again that will include the purple receipt plus the latest green RAV, right? So that's how we just add to the aggregate kind of recursively over time, right? I don't know if it's a good time to look for questions, because that may have been quite information dense. I think there's some questions in the chat already. And then I may go even more in detail afterwards, just to give an idea of the structure of the data that's exchanged.
I think Derek's question was already addressed, so and I'm not seeing anything in the chat nor anyone raising hands. So I think we can continue, Alexi.
Cool, awesome. Cool. Next slide then. Okay, so what's going on? So I'm giving more details to try and convince you that it's secure. But if you still think it isn't, I'm interested to hear, of course. Okay, so the tap receipts, these are gonna replace the current non-tap scalar receipts that we already have today. What they have is that they contain an allocation ID, because every state channel in the system is allocation specific. So allocation
Did we lose Alexi? I think so. Yeah.
Yeah, sorry, my internet cut out for a second here. So I was saying that the GRT value is 128 bits, and that's enough to store the amounts of money that we expect from queries. You can already go into at least the thousands of dollars, I think. So it's okay. Unix timestamp in nanoseconds, and that timestamp is used for the timeline part. of the protocol, and a random nonce just to make extra sure that we prevent replay attacks, basically. So we make sure that every receipt is unique. It's unique because of the unique timestamp and the unique random nonce, right? So that's really just, the nonce is really just useful to protect you in case for some reason you get 2 receipts at the same timestamp, which is normally unlikely. And if it even if it would be, even if it would happen, the indexer would refuse a repeat receipt, because then the problem with the repeat receipt is that if you send it back to the gateway, to the tap aggregator on the gateway side, it may say that you're trying to do a replay attack because it's the same receipt. So the indexer should refuse itself repeat receipts, right? And yeah, and then the ECDSA signature, the same kind that you would use for normal Ethereum transactions, right? So it's a SecP 256K1, the normal. You would use an Ethereum address really to sign this. And it makes it extra easy to check on-chain also, right? Next slide, please. Okay, and the receipt aggregate voucher, what it is that it contains the data packet is just allocation ID, an aggregate value, and a timestamp. The timestamp is to prevent older receipts to be re-included again in a later aggregate. And then what you can do here is, first, let's say you have the first RAV of your allocation. You will just submit the receipts that you've received up to a certain timestamp. You send them back to the gateway. The gateway will check that the receipts are signed by itself. It will create an aggregate, sign it with its own key, send it back. So that's how we get that first packet that ECDSA signed, the RAV1. And then as you receive more receipts, you may request again a RAV. The second time around, you give the receipts that are at a later date than the previous RAV, and you also give the previous RAV. Once again, the gateway will check that the previous RAV that you've submitted back to the gateway is signed by itself, plus receipts that are also signed by itself. It will aggregate everything and sign RAV2 and send that data packet back to the indexer. And so the goal is that at any given point, I mean, most of the time you have a RAV that small data packet that just contains the amount of data and the allocation ID, and that is signed and that you can send back on chain to collect your fees from the gateway's collateral. Yeah, pretty much that. I think that's all I have here. I went through most of the high-level things. I don't know if maybe Sevi or Brian would like to add more things, and perhaps we can get some more questions if people are curious.
Yeah, I think you covered it pretty well, so we could probably open it up to questions.
Yeah, folks, feel free to ask in the chat or raise your hand, and I'll and you'll then be able to unmute. In the meantime, Alexi, I believe we'll be sharing more details on the timeline, right? Like what it means for indexers when they will need to upgrade their software. But I don't think we've covered here the backwards compatibility with the existing gateway implementation and the indexer software stack, but all of that is in the GIP as well. Yeah, I don't see a lot of questions. All the details will be in the GIP I just mentioned. It should be on the forum too as well, so we can continue the conversation there. And maybe in a month we can get back here and do a follow-up call on the actual implementation plan and yeah, how indexers should go about and upgrade their stack and how to do it. All right, I don't see any questions, so I think we're good.
Cool.
Yep. All right. Thank you, Alexi.
Thank
Thank you, Brian Sevi. Okay, Yaniv, you're up. Is Yaniv on the call?
Yes. Hey.
Hey.
All right. Hey, everyone. Today I'm going to show an update of Geo. So at Geo, we want to make it really easy for anyone to add content onto the graph and to organize their knowledge and information, and then be able to browse and interact with it. So I want to show just some of the content that people are adding so you can get an idea of what the community's been up to, and then some new features. So I've showed some of these spaces on previous calls, and we've been adding new spaces to Geo. So some of these things are, adjacent to, the work that we're doing in the crypto space. So for example, we now have a software space. A lot of the stuff that we do in crypto is software, but software is its own industry as well. So, it has its own skills, different maybe development fields or areas, programming languages, frameworks, right, for the different programming languages that might be used, for example, front end, back end, mobile, something like that. Different design patterns, and maybe we want to see something like, what's the command pattern, and there's a little page here on like these different design patterns. So any software developers could organize their knowledge around software in the software space. We look at the education space. This is an important one. Or actually, sorry, maybe I'll do cryptography next. So I'll start closer to the stuff that people are doing, and then we'll start to move further out. We also use cryptography. And there are a bunch of interesting topics related to cryptography, Starks, signature aggregation, Jameer secret sharing. Say we wanted to look at something like this. So we've got pages for like all these different things, different ciphers. And what's cool is, all of this stuff is searchable. And so from anywhere you can do a global search, and you're like searching the graph for content. So if I want to find something related to Shah, I can do that search and jump straight there to the page for SHA-1. And here we have a whole kind of guide that explains the SHA-1 algorithm. So that's pretty cool. Going, outside of things that we're already doing, but, this is stuff where there's probably people on this call that are knowledgeable in these areas. Education is really important, right? And we're capturing different goals. We want to teach literacy to everyone, train great teachers and educators, teach basic math to everyone, teach critical thinking skills. One of the goals here is to provide vocational training for useful jobs. And so here we have like a list of vocational fields, things that maybe you don't need a 4-year degree in order to do. So we could look at like healthcare and then see like what are different like sub-vocational fields within healthcare. Maybe people didn't even know that like pharmacy technician was, a job area. So you could jump here. And everything's loading just a little bit slower for me today, but it's on the hosted service where we're working. Hopefully we'll be migrating over to the network this month. We just need to switch over to file data sources, and then we'll be able to do that. So here we can see different like guides for being a pharmacy technician. Maybe I want to look at this one. So people can, learn about different roles and find different like training programs, get their certifications, and have all of this stuff. You could also, imagine people here curating courses and lessons for like every topic. It could start out with just linking to existing courses on things like Udemy and Khan Academy, but people could maybe, start to rank those. So you could find the best course on any, topic, from any subject. And then maybe eventually people are just publishing natively on Web3. The psychology space is really interesting. So we're working with an academic psychologist, and we're doing a lot of work related to social work. With our work to end homelessness in San Francisco, and so we have this psychologist is going through and adding a bunch of studies to things like trauma and motivation and things related to homelessness, and so we're capturing these studies from these journals. These are the authors, and then claims. So maybe there's a claim here that higher scores on the personality trait conscientiousness are associated with higher income and wealth. And we can see where does this claim come from. It's this is the source. It's a study. These are the authors, and then here are a bunch of different claims that came out of this study. And so now you have a place where if people want to debate whether the study was done correctly or not, they could do that here. And you could have all the arguments why the study was done correctly or why it wasn't. And if the experts basically debunk that this study wasn't done correctly, then we know that we shouldn't count on any of these claims that came out of here. And so so many things end up being these issues where people are talking past each other, and we don't even have like a basic set of facts that we can agree on, and so it's hard to have higher level like policy conversations. So cool to see here in the field of psychology we're starting to do this, and get to a set of claims around psychology and how the mind works, personality types, and things that we can use for to inform our policy decisions in areas like social work. And this could also be useful for things like education, maybe to try to find out things around like personality tests and what types of jobs or career paths would be good for people with different personalities. So that's interesting. News is one that I'm excited about. We just have a starting place here, but similarly to combat fake news, could be really cool to have basically a list, like imagine if every day we pulled out the stories of the day, big world events, and then we capture like the world events themselves with a link to the different articles. And then people can go through, and if there's like journalists that are consistently writing like misleading articles, that could be tagged by the community so that we can combat problems like sensationalism, fake news, things like that. Start to have some accountability because people can like organize all of these things that are happening. And then, so just to show like some of the new features, we now have Find or Create. So this is just a starting point. We just created this music space. And so let's say that we went to this album, OK Computer. So I'm in edit mode now. And right now we have one track called Airbag. It's the first track. Maybe I want to add another track. So I'm searching to see if like Karma Police has already been added as a track, and it hasn't. So 0 results found, but I can just create the entity right in line. And then it knows that this thing is already a track. So I can click on it, and it already presets that it's types track. And so it adds fields that are relevant to tracks, albums, and artists right there. So now it's like super quick to create new relations, whether things exist or not. So, these initial editors are being like super productive in adding content. And last, we can now like view the history of like any page. which before we couldn't actually see the diffs. So, if we're on like this page, I can see the history of this page. So the last edit was on July 2nd, and I can click on this and see the diff. And of course, each of these proposals are anchored on chain. And so this is untamperable history. So imagine you can now really have like version control where you can see, the diffs and the full history of like, eventually the entire web. So those are some of the updates to Geo. We're making lots of progress. If you want to get involved, we have a Geo Explorers program. We meet every week on Thursday. We give out prizes in GRT to the top editors every month. Next steps are going to be for us to start adding some more social features to get towards a permissionless onboarding process where people can create their own personal spaces. And then also have the ability to like upvote and downvote, so we can work towards starting to rank lists of things, lists of anything. So that's our update.
Very cool, Denis. Thanks so much. It's pretty cool to see how it's evolving and this user experience being on par with Web 2 options, but with Web 3 technology, so way better. I see Alexei has a question in the chat. Who gets to create, edit the content? What happens if there is a disagreement?
Yeah. So for right now, we're manually creating the spaces and manually adding the editors, and then the editors can just kind of publish their content directly. But we're going to be rolling out governance later this year. And so the idea is each space will be able to define its own governance rules. But once we have governance, if you want to publish a change, there will be like a set of editors, and it can be configurable, but basically the changes go to a vote. The editors would vote on the change, and only if it's approved does it go through. So that would be the time to resolve those sorts of disagreements. And it's interesting, even something like a GitHub tends to be that like any maintainer can just approve like a PR. But GitHub repos tend to be more like controlled by a smaller number of people. These are public spaces that are meant to govern like industries and larger things. So having like a more democratic voting process, I think, is really interesting. But they can, we still want to play with things like reputation weighted voting. So that it doesn't need to be one person, one vote. There's lots of different ways you could design these voting systems, and I think that's going to be a really huge and interesting area of exploration.
Very cool, very interesting. Thanks, Yaniv. Amazing to see this great progress. You guys move fast too. We've had some updates a month ago, by the way. If you want to check back what Yaniv presented, you can always go back to our YouTube channel. We have all of these recordings there. All right, we have to move with the agenda, a little bit behind. Thanks, Yaniv, again. Always a pleasure having you. Sebastian, Fubi, sounds like there's two people, but just one. Sebastian and Denis. I mean, maybe we can talk about the two last items because they're all kind of related. And I know, Denis, you've also worked on Substreams JS. Yeah, feel free. Let's start with Sebastian. Denis, just jump in whenever, really.
Yeah, that's good. This is totally related, and so I'll definitely ask Dennis also for his input. So hey everyone, this is fresh off the press. We have a Substreams JS implementation. This is essentially a not to say copy, but like a port of the Substreams Go package from Streaming Fast in terms of functionality. It's not intended as a copy of the CLI. The CLI obviously is maintained best by Streaming Fast, but this is definitely covering all of the functionality that the CLI also here is based on. And it's intended as a JavaScript, web native, portable, TypeScript-based, ESM-based library that can be consumed in pretty much all JavaScript environments. So it's capable of running in the browser. It's capable of running in service workers, Cloudflare functions, Vercel serverless functions, AWS Lambda, Node, Bun, Dino, and yeah, just pretty much all environments. This means you can, using this tool, you can consume data from Substreams in all of these aforementioned environments, but you can also interact with Substreams packages. You can interact with Substreams manifests, so the development time representation of a substream, like the YAML manifest and the WASM implementation of the Substreams code. And then you can send those Substreams packages or the manifests after they are compiled and packaged into an SPKG on the fly. You can send them to the Substreams gRPC service and read data from there. Let me show maybe. So there's a couple of examples in this repo too. By the way, if you want to try this out, there's some instructions in the repo too. Essentially, you just clone the repo and install with pnpm. You can go to one of the examples.
Can you zoom a little bit, please? Oh yeah, Alexi, that's in the same. Just, yeah, perfect.
Sure, yeah.
Thanks.
Yeah, so basically this repo, you just clone it, pnpm install, and check out the examples. There's examples for a couple of different environments already. There's one for Node, there's one for web, so browser consumers. There's one for Node where you actually just opening a Substreams manifest and then bundling it yourself in the code here and sending it to the gRPC service. And there's also one for compiling a Node stream consumer as a standalone Node binary. We'll look at this Node example also on screen share in a second. So all you need is an API token, the same as you do when you are interacting through the Substreams Go package CLI. You can then fetch a substream from a URL, or you can fetch a substream from a local source, like a relative path to a YAML YAML manifest. And yeah, just a bit of boilerplate code. Dennis has some shorter versions of this in his Node and Sync packages that he'll surely talk about right after. But basically, yeah, you can then consume the stream directly in your TypeScript or JavaScript client-side code and do whatever you want to do with the data. So let's run one of the substreams. So for instance, in this example, I've prepared, we are running the Uniswap substream. So this is running the Uniswap substream in Node.js locally. So I've previously already set my API token, and also zooming in a bit more here. Now, when I run this example, you'll see that within this Node.js consumer environment, I actually get the Uniswap pools printed out. I'm consuming the map pools Substreams module. All of the native TypeScript or JavaScript debugging tools are also available. So you can set a breakpoint here and consume it directly in your VS Code or whatever editor you're using. Here you see block by block what pools are being produced by the module. So quite convenient. If you're more familiar with TypeScript than you are with Rust, and you are wanting to consume substreams in JavaScript, this should be fairly straightforward. There's also a demo, and I'm going to show that app in a second, for how you can use this in the browser. So for instance, here in this, I'm going to share the link in the chat right after. In this web app at substreams.vercel.app, you can also see how this is functional in the browser itself. So you just drag and drop a package right here in the browser. It opens the package, kind of like decompresses the SPKG, and then shows you all of the modules that are included in the SPKG file. Then you can select the module. You can choose a couple of, like a block range that you want to run the module on, and then it streams out the data in the browser. So this This is now possible in the browser because we are using a gRPC client package that has recently been released only like at the beginning of this year. That is web native. It uses all of the web primitives. It uses native HTTP fetch. It uses an HTTP transport instead of the standard gRPC binary transport. So you can also consume data in JSON. And recently, I think like 2 weeks ago, Steph from Streaming Fast has added support for this directly on the gRPC service that is currently hosted by the Streaming Fast team. So this is actually now possible right on top of the official Substreams Streaming Fast service without any proxy or so in between. This is pretty fantastic. Yeah, if you want to try this out, there's also 2 Substreams modules that I've put right here that you can just start from without uploading your own. But you can also grab a Substreams package from for instance, the Uniswap substream here. You just go to the release. Sorry, that's the wrong one. You just go to the release, download the SPKG file here. There we go. And then you just drag and drop that in here. And yeah, you're ready to go. On top of this, we would like to build a Substreams registry in the future. So just like a package manager UI that you can use to browse and explore existing maintained high quality substreams. You can download those then and also explore the data from those substreams in the browser. That's the second tool, like a Substreams Explorer that lets you do this, that this tool here right now does, but in a more fine-tuned manner. So this is obviously a very early prototype that just shows the functionality that's possible in the browser now in JavaScript natively. Obviously, it's not well designed or anything like that yet. It's yeah, very early work. But yeah, Dennis, maybe you want to jump in.
Yeah, like I said, all the tools for like anybody who's familiar with JavaScript are kind of in that Substreams core or the Substreams node library. So there's some handy things that I think you might have mentioned, but one of it is the like read package. And I don't know if you have an example of that one. The read package is kind of like a bundler to fetch from HTTP, file system, or reads directly from the manifest. So it's exactly the same. It's exactly the same sort of behavior as the Substreams CLI that you can expect. So it kind of handles all that, voodoo magic. Is it a URL? Is it a manifest? Is it a file system? So that's a pretty nice feature that you can kind of have the same similar features from the Substreams CLI in your JavaScript libraries. And yeah, like I said, it's maybe we need to kind of work on the documentation to kind of showcase all these nice features, but there is essentially a lot of feature complete there. And I think you also have the module hash, which is also pretty important for caching. So the get module hash, you can be able to compute the module that you're working with if you need to store it as a, if you want to store it as a cache or something. So all the powerful things in the Go Substreams CLI libraries are kind of ported to this JavaScript library. So it's a one-to-one, I think, or close to.
It's one-to-one minus the CLI. So the CLI, obviously, because this is not supposed to be used as a binary, right? It's more like a library that you use in your like bespoke implementation for reading your own substream. You could build a CLI around it because the underlying functionality is implemented one-to-one, and there's tests that actually verify that there's bytes to bytes identical IO behavior of this versus the Go package. So for instance, the module hashes computed by the Go implementation are identical to the Go to the module hashes produced by the JavaScript implementation, and validation of the manifest is also identical. So yeah, I actually have a list of features, so maybe I can quickly go through that. So you can parse and validate Substream manifests. You can package Substream manifests. So just like you can package manifests into SPKG files in the Go tool, you can do that here as well. You can load existing packages. You can also load existing manifests and traverse them for all of the dependencies and extract the protobuf types, extract the modules from them, repackage them, merge them into like a combined SPKG that has two like parent SPKGs in it. You can submit them to the gRPC service to consume their output, the data that is produced by them. Yeah. And you can generate, there's also a Mermaid implementation similar to the graph CLI, the Substreams CLI Mermaid graph that you can produce there. You can also do that in here, but that's, yeah, that was mainly done for fun. But the point is, it's like the underlying functionality should be implemented as a one-to-one port of the Go package and be absolutely well, not feature complete, but identical in terms of output, bytes for bytes.
Nice. Yeah, I can imagine this being super useful for hackers or people that just want to hack something together on the browser and demo something during hackathons. And it's pretty cool to see that it's suitable for front-end developers, because most of them just use JavaScript or the whole JavaScript ecosystem, and Substreams haven't been so far super user-friendly, let's say, for those. So I'm pretty excited about this.
For front-end developers, I also intend to have like this. There's already a React package that you can already use. There's a hook called use Substream that you can use in your React front-end applications. So just read and consume a Substream directly in your React app. Yeah, definitely needs a bit more work. Like this is early stage development here. This package especially, but definitely something that I'm interested for my own use cases too.
By the way, we'll have an hackathon starting next week, ETC Paris. Folks wanting to play around with Substreams, you can definitely use this tool, and we'll have some bounties as well. You should be eligible for rewards if you build something cool. Just plugging that in there.
You want me to share the ERC? I think everybody can see the ERC.
Yeah, we can.
Perfect. So based on all the JavaScript libraries, now we can play with also the Substream stack, and we can kind of build some interesting things. So during the ETH Waterloo hackathon, I kind of just hacked away an ERC20 token, token transfer and balance lookups, also approvals and stuff like that. So one of the things that we can show is we can actually make a generic ERC20 token that streams all the events and the token transfers and the balance changes without actually hitting the RPC node. So it's all stored in sort of like in state. So here, I'm going to do a live, it is working. So right now it's not currently fully synced. There is definitely some ways to kind of improve the speed and the syncing, but that's more on the infrastructure side. But at least for what is currently synced, we can then, I'll showcase after the Substream Rust code, but you can query any transfer of any address of every account, as long as Postgres is still keeping up with the data storage, because it's a lot of transfers. And you can also filter, do all the things that you're familiar with, which is essentially filtering by, let's say, address. So you can say, only find me these transfers from this token contract. So now we're filtering by token address, but it's not hard-coded in the subgraph. So this is indexing every single token that matches that pattern. The other thing too, we have also balances as well. So you can look up account balances. So every time that there's an account balance change, let's see if it works. It should. It's a bit slow, maybe. It's trying to fetch new data for it's cached. But every time that there's a new balance change, the states of the users or the states of the balance, they are stored in the block. So you don't actually have to fetch any RPC node to do a get call. So you can store all the balance changes and all the state changes and fetch them and extract them really easily. I'm not too sure why it's taking so long to query. Maybe it just needs to cache. But let's see. Let's stop this query. Oh, there we go. Okay. You just so now we have the owner, but this is again, this is just finding the first entry. But you could, if you wanted to, say search by owner. So let's go search by owner. Oh, failed to fetch, but and then let's go find 10 of them. Okay, there's only one address on only one balance for this user, but you can essentially do all that query on any owner, any address, any contract, and any parameters that you would configure your subgraph. So what I can do is I can show you a little bit. I know we're kind of pressed for time a bit, but I can show you the where that code is located. So we have this little Substream cookbook repo. It is also hosted on the Substreams documentation. So these are just advanced patterns that we've been kind of defining based on the Uniswap v3 subgraph substream. But in here, we have also that working example, the ERC20 token Rust code. So you have all your things that you would be familiar with, your schema, so your GraphQL schema, your subgraph YAML. So this is, you would just put in your SPKG. This is your substream package. You would define your module name. This is the graph out. And it's a pretty easy configuration. You know, it's really not that complicated to set up a subgraph powered by Substream. And then I'll show you one last thing before we can wrap it up. Here, this is a map module in Rust to extract that data that we would just visualize. So the map transfer is simply just iterating over all the logs, so all the block logs, matching the event, so the transfer event. So we've decoded the ABI, and now we're just pushing that event to the as a map module. So now we're at 35 lines of code, and most of it was more some comments and some definitions. So it's really not that complicated to kind of build some of these map modules using Substreams. You would just need to find the ABI, decode it, and iterate over the events. And then you have a stream of transfers of every token contract. The other thing too is the map balance, very similar as well. You can just iterate over all the calls, so block calls. You can kind of do some filtering. This is kind of like making sure that the calls are specifically for map balance changes. There's some improvements here, but that's a GitHub issue. So we just want to make sure that we're only filtering by certain method selectors. And then once we've identified that this is in fact a balance change, we can store and iterate over all the calls, all the storage changes, and then save the balances. And that's it. So it's relatively straightforward. The only thing that is kind of needed is the validation and making sure that we're selecting the right data. And then in here, we can use Sebastian's UI to go and visualize that data as well, real time. So if we can kind of like say, we want to take a map transfer stream, and then you can see the same data that we saw in the subgraph studio as well. So if we want to go and look at the balance of, I can't click here, balance of, oh, let's go and use a higher. 1,000 blocks. Let's go a bit higher. There's an error. Okay, well, testing and live. But anyways, we'll redo that another time. But you get the gist. So maybe we can share the URL of the cookbook, and you can look at the example and the Rust code. There's also some information on how to kind of like which methods are being used and displayed for extra information. So that is what I have to share for today.
Very nice. Thanks, Dennis. Again, I think it's early days, right? But it's very promising. Something we haven't done or been able to do with subgraph technology alone, let's say. It's been super slow, or not even being able to keep up with Chainhead. But that's not the case with Substreams, and especially if you use Substreams-based subgraphs, we're not too far off from a future where we can have GraphQL APIs for all of these token balances, holdings across multiple chains. It's going to be super, super nice. I see some questions, so I want to make sure we go through some of these. Dennis, Derek is asking, could someone start listening to the chain head and utilize these as a way to subscribe to new events? So basically getting real-time information, right?
This is a very good question. I actually built a service worker that runs directly in the browser using Substreams JS and tracks the cursor, which it like last process, and just continuously monitors also after restarting your browser for certain events, and then sends you notifications using the browser notification API. So you get notifications for whenever a transaction of a certain type of transaction that you're monitoring appears. Yeah, so that's actually possible, and it's a really interesting use case. Yeah.
Can you share that by chance?
Yeah, I can actually. I need to remove some internal pieces, but yeah, I can. It's something that definitely makes a good example for the Substreams JS repo. So I'll put it in the examples repo there.
Yeah, and we've got some initiatives as well to kind of implement some like substream webhook connection, which is essentially a lot of users want is they want to load their page. A user presses, pushes a transaction, and you want your application to get that instant feedback whenever that transaction is in a block. So whether it's a webhook or a WebSocket streaming service, all of these things can be built for sure. It's just kind of in the early days, and we've got Sebastian, and we've got some code here. So I think those tooling and those sort of tool sets will be made available for sure. So WebSockets, webhooks, or directly connecting to gRPC Web Connect. Those are things that you can do today. You just need to get the tooling involved. But I think we have some examples that we can share, but they're in early beta prototype stage.
Nice. Not too far off from having proper social media type of use cases in real-time information, all powered by Web3 on browser, like in real time. Super, super cool stuff. All right, folks, we're at time. So I was not sure if we would use the whole time. It sounded like, well, we did, which is great. Yeah, last minute, like folks, last questions before we wrap up, just to make sure we cover everything. Feel free to comment in the chat or raise your hand. Nope. Okay. Thank you all for your questions. Thank you for presenting, Dennis, Sebastian, Yaniv, the whole semiotic team. Thanks so much. I'll see you all in a month. We'll be in Paris as well, as I mentioned, ETC. So feel free to drop by our booth. We're happy to talk about substreams. They're coming to the network soon, at least the substreams-based subgraphs on Ethereum mainnet with indexing rewards, something we're working on right now. And hopefully we'll have it in time for ETC. And yeah, thank you all for coming. I'll see you in a month. And again, this will be on YouTube as always. Thanks all. Bye.
Thank you.